All right, so this is going to be Will Richards doing another walkthrough of the manager and module for Loom. This is fall 2023. Take it away. Well, make sure your mic is unmuted.
Hello? Okay, solid. Yeah, so today we're going to be going over the manager module setup in Loom that is effectively the backbone for how it all works together and whatnot. Yeah. So the module effectively just acts as an abstraction layer for every sensor that's included in Loom. When you create a new sensor, you need to implement the module. So for example, what that looks like, if we go look at the ADS 115, we can see, actually this isn't a good example because it's doing that. Hold on. There you go. It will implement the module as follows here. And basically what that allows us to do is, since the module has these functions down here, so these are called pure virtual functions. You can have just virtual functions, but what makes these pure virtual functions is denoted by the equals 0 that comes after it, which basically says that when you implement the module in any other sub sensor or actuator, whatever that may be, is that you need to specify a override for these functions explicitly within the sub module. Otherwise, it'll break and cause compiler errors and whatnot. And the reason that is because these 5 modules or methods rather are used by the manager to interact with all the modules seamlessly. So if we go and look at the manager, you'll see that there is representations of each of those here. And what that allows us to do is you can just call initialize on the manager, and because you registered the module with the manager, it will just go in and call the specific initialize function on each module that you then specified the new parameters for. So like here, if we look at the SDI 12 module, and then we go to the manager or measure function, we can see that this is the implementation for what happens when you say measure on this module.
So let's test our knowledge then. So let's say RV, what's the difference between the module and the manager?
Manager.
Key difference, what's the difference between the module and
the module is an abstract class. The manager is a totally normal class that just has, it actually doesn't even inherit from module. It's the only one, actually, I think, that, and apart from that one, that doesn't actually inherit from the module. It basically, it holds a list of modules down here in the manager. The first, actually, it holds a list of pairs technically, but the first element of the pair is the name of the module, and the second one holds a pointer to the module itself. So, and effectively, when we call initialize or measure or package or whatever, all it's doing is it's just looping through a list of, it's looping through that list and then calling the subsequent initialize function on the submodule. Because polymorphism works how it does, it'll execute the specific code of that module without actually needing to know any of the specifics of how the module operates.
Great. If I can add some human readable things here. So the idea is, Loom is comprised of a system of components. And we're trying to, well, every system for like whichever project's going to make a use of a subset of those components that we've already integrated, or it could be they use components that haven't been integrated yet, but we're going to assume they're going to use a collection of some of these components. The manager is sitting like on the top of everything. It's like that frontal cortex is like just gonna, organize, all of those other components, which those components are gonna inherit from module, right?
Yeah.
And then manager is gonna create a list of all of those components, and by it doesn't do it automatically. You actually have to register.
Yeah.
Every one of those.
I'll get to that in a second.
With the manager, and that's how the manager goes to list of those things. And then there's all these fun generic functions that every one of those components are going to have access to. What are those functions? $167.
Which are
yeah,
Yeah.
that's the most key thing, right? So initialize, measure, package, carry down. Those are just like generic like commands, right? That every module that is registered with the manager needs to handle that.
and
So different.
yeah. With that said, it doesn't technically have to provide any functionality at all. It just needs to acknowledge that those need to be overridden. So a lot of sensors and stuff actually don't have definitions for the power up and power down. They're just like they're just overridden with nothing. Which works totally fine. It'll just call it and then immediately return because there's nothing to execute.
What would happen if I didn't put override there?
It would error. You wouldn't compile.
Right. So that might be a typical problem for like someone just getting started making something like a new, right, new copy. Great. Steve, do we have any other questions about the relationship between module versus man now?
So, it sounds like you're saying it correctly, the manager has a lot of components that are from module that you can use for different sensors. You can have a list of them all in one place.
Yeah, sort of. It's pretty close. Basically, manager just has a list of modules that it can manipulate however it sees fit. And the reason we can do that is because in C++ you can treat. So basically, if you look at like a tree, kind of, you have the module at the top, and then every child of the module object is also technically a module. So if you just treat everything as a module, it removes all of the specific functionality to that object, but it still allows you to access these 5 functions because they were explicitly stated that they will be present there. And so the compiler and the computer knows that those are valid functions that can be used on every single sub module. It's just it's a very straightforward implementation of like polymorphism.
So does that makes it easier to write the sensors?
Yeah, because you have a known, yeah, you can treat the module like a blueprint. And then you build every submodule off of that initial blueprint, so that you can treat them all as the same type technically, even though they're not.
And I think if we need any more, we'll keep rolling over more of these concepts. And... Okay, great.
Yeah. So the module also has a couple other functions other than these that are overridden. They're required to be overridden. This one, so basically the virtual defines another abstract method. However, it doesn't require that it be overridden because the it's already defined here. But if you want to say do something different, like get module name, for example, without any other additional modification, it'll just return whatever module name is passed into the constructor up here. With that said, if we look at the actuators class, which is another subchild of module, but still another abstract class, it just provides functionality that's specific to managing relays and stepper motors and whatnot. We can see that I modified somewhere here. Did I not? I definitely changed some part of it. I can't remember what now. It's not there. Oh, okay. Never mind. Oh, I know where it is. It was one specific relay that actually caused problems. It was the relay part itself, where I believe I modified the effectively, because if you have more than one relay, the format of how it so initially every module has its own name that has been given at some point, usually in the constructor here. Well, where is it? Oh yeah, we do it differently here, but the name is set in the module constructor. Sorry, hold on. I got ahead of myself a little bit.
Sorry, yeah, you have to back up.
Yeah, I will. So let's say you want, let's leave this one actually. Same idea. This will just print out the module name formatted like this. We don't actually use this anymore because this was an old thing that we used to do before the logger class got added. That has all the nice print statements and whatnot. But it basically is print out whatever the current module name is, followed by the message that you pass in. And so let's say you wanted a slightly different print statement here. Instead of just printing the module name and the message, if you wanted to add another parameter here or whatever, you could then override this in the specific class. And so whenever you called print module in that class, it would then use that class's implementation instead of this. But while still also maintaining the idea that this same function signature will exist within that class. Does that make sense?
So you can basically override what the inherent functionality is by specifying its unique functionality further.
Yeah. Yeah. And the reason I went to the relay to try and find that is because if you don't specify it, it's just gonna create the name however. So let's say it was a relay. So it's just gonna set the module name equal to relay, like it does. Or actually, whatever. It changes it later. But if you have multiple relays, how do you know which relays you're talking about in the correct context? So if there are multiple, then it will take into account the fact that when you're adding a new device, it will rename the current one to append whatever pin the relay is controlling or whatnot, so that you can specify what device is actually outputting. We do this with the MS-5803 because it has two possible addresses, and you can have two devices hooked up like on the weather chimes. It will notice that there's already one in the, I'll tell you where that is actually. It'll notice that there's one already in the list, and then append the address to the end of it. So instead of just being MS-5803, it'll become MS-5803 _ 119, for example, that was the address, or 118. Which brings us to this register module function here, which is actually pretty much the whole backbone of how everything gets brought together. Inside each submodule, every single module also takes in a reference to the manager. And that allows us to have general access to device name, instance number, the JSON packet that we store all the data in, as well as this register module method here. And this should be called in every single constructor of a submodule, and effectively without having to do any other weirdness of adding like specifically in, it'll just do it when you construct the object in the sketch automatically. And it just takes the this keyword in this case is just it's a pointer. This returns a pointer to whatever the current object is. And so in this case, it's Loom STI12, but because that inherits from module, we can just say that it takes in a module and it strips away the rest of the information like we were talking about before. And then initially, this was basically just takes in the module and then pushes it onto the modules list. But we realized that we need more than one sensor at times, so this whole thing was added here. And effectively what that does is it just loops over the current list of modules and checks if the current name it already exists for the current module, and then if it does, then we add on the specific identifier, and then set the module name of the module in the loop to the new one, and then actually set the current module that we're adding to the new name too, so that they both change instead of having one just remain as it was before.
We need to make a note when we talk about the multiplexer stuff down the road.
Yeah.
About its relationship to this, or if it's not.
It's not actually, but yeah. The multiplexer handles all that in itself.
Great.
But yeah. Just some helper methods and whatnot. This just will return a reference to the current JSON document that holds all the user data.
Under what circumstances would you use that?
If you want to manipulate the data in a module, it's like if you want to grab data out of the current document, yeah, it's just a reference that you can do whatever you want with.
So is that the primary way you would query?
No, or not for adding data. This was how I did it before, and then I realized that that wasn't going to work because the format was completely different in this version than it was before, and so I had to go back and make sure that it fit, because then other stuff would break down the chain. So don't really use this a ton, but it's there if you want to use it for whatever that may need. Try to avoid it though.
Or they're easier.
Yeah, I'll get to that. This is effectively just a fancy way of doing while not serial. Basically, when you plug in a live controller, it's going to start running as soon as it gets power. Which in a lot of cases means that if you have print statements at the top of your setup or loop, they're just going to fly by and you're going to miss them. So basically all this does is it just initializes the serial monitor with that whatever baud rate the define is set to. In this case, it's just always going to be 115200. And then it enters a while loop that checks if either the serial, or first of all, it checks if the serial monitor is not open yet, and we actually want to enable this feature. You can, if you just say begin serial false, it'll just go like normal. But if you have that set to true, it'll wait, and then during that time, if you don't want to wait forever, because if you push the same code to a device and then try and deploy it in the field without connecting to the serial monitor, it's just going to sit there and hang forever. So you just add a timeout here that just waits for 20 seconds or 2,000 or 20,000 milliseconds. And then if that is expired, then it just breaks out of the loop and continues with the code like normal. Here's our measure function in the manager. This just once again checks if we've called the initialized function. The measure and package functions were added first, which is why they're further up the list. The initialize is down here actually, but you'll see it has initialized to true at the end. And basically, you don't want to call measure or package or whatever or any of the other functions without actually initializing first, because that doesn't make sense. And also it'll cause problems, which is why we check, and then if that's the case, then it'll yell at you down here.
In setup when you initialize your stuff, you're specifying to the microcontroller and how all these things are.
Initialize and power up are different because initialize is just called on in the setup. So the first time the microcontroller powers on, while power up is mainly used between sleep cycles to initialize, but not quite initialize the devices. Usually there's more code in the initialize block than the power up. Yeah, measure, it just loops over the list of modules and calls measure on them. And if they're not initialized, then it says they're not initialized. Fairly straightforward. Yeah. These are results of the logger here, which we'll cover at some point. There's a wiki article on it that some of you have already read that has some more good info there.
Yeah, so it's important in measure to point out that the fail safes that will design in, right? So one of the big issues with him was the whole like failing gracefully with something like is it responding or something, you declare that you will use the sensor in the code, but actually the hardware, like you forgot to attach it or like it just didn't attach for some reason. We don't want to hang the system, right? So the what line of code here do you think like might prevent a crash? 62, 87.
I feel like there's two. So
That would be the check. Everything semantically remember like, oh, I'm not there because that wasn't there, and we're expecting something like that. But the statement is that else.
If it does work as
there was one, so
Right. What line?
82, 83.
no, this is just telling you that something went wrong. Let's actually
check happening.
There's one. Now it's checking if the sensors have initialized. And there's also another to see if the specific module has it.
You see where that is?
Yep.
Yeah, and send
So,
another
all right.
question.
Moving on. Package. This takes all of your data that you've collected. Measure is meant to hold data from the sensors and store it locally in a variable somewhere. That's it. That's all you do in measure. Package is where the data is actually formatted. And what this does is it takes so first of all, it clears the JSON document. There's just a global document that's inside the manager where everything is stored. First of all, here, what we do is we set up some basic boilerplate JSON stuff. We're setting the name of the device and the instance number just to it's like the ID tag is the top, and then inside there's another key that's called name and instance, and then those are equal to whatever the device name is and instance number. And then all of the sensor data is stored inside another contents array that is then populated based on whatever sensors you're using. So then you call the specific package function for each module down there, which has its own specific implementation. So like if we go back to the SDH12 stuff and look at the package function, we'll see here that we're using this method get data object, which is in the manager that I'll get to in a minute here. And then once we have that, we can then add whatever our specific keys are for that module. So this is a soil moisture sensor. So we're looking at the temperature and the dielectric permittivity and the conductivity or whatever. And we're just setting those equal to local variables within this class. So basically, we're just formatting the data into a way that's more easily readable. Speaking of which, this method here, basically all this does is it just creates a new object, a JSON object inside our global document with the name of whatever module we are trying to store data in. This is just checking if it already exists, and if it does, then it'll just store the data in whatever module it's already there, so that it doesn't completely overwrite the pre-existing object. Yeah, and then it returns a reference to that object so that you can then actually modify the data within it. Power up pretty much just calls power up with all the safeguards as the just has not initialized
So
whatever.
that's attached to the Hypnos power rails?
No, this is not.
Oh, it's not?
No.
Power up? Oh, it's not?
No. This is a general manager power up. The Hypnos power rail stuff is managed inside the Hypnos' own power up class. This is once again just calling general power up functions.
For all the sensors? Or
Yeah.
For all
For all components. Yeah. This is power down, same idea as power up. Display data basically just takes the this is what's added in a more recent version because we want and as well as the virtual parameter for the display data. Most modules don't have any display data functionality, but the OLED, we want that to also update at the same time as we display data to the serial monitor. So this part was added so that will happen on those modules. And then all we do is we just basically pretty print the JSON format out. So that basically just means printing out the JSON document with indents so that it looks nice. And then we log it to the serial monitor and the SD card using a logger. Yeah, initialize. Virtually the same thing as the rest of them. It just has it knows. So the manager, since the Hypnos is such a key component of almost every project, the manager should probably have some idea as to whether or not we're using a Hypnos. And if the Hypnos is disabled and we try to initialize the modules and it's in use, nothing's going to work because there's no communication going to any of the modules, because the data rails and the power rails are physically cut. And so that will just yell at you that you've done something stupid and you need to actually enable your Hypnos before you try and initialize stuff. And then it just reads the serial number from the Arduino itself, and then just logs that to the top of the.
So, every chip has its own unique serial number, which is a really great way of identifying this is a specific device from the factory. No other device that comes out of the factory has that for regardless of like what the device means. You get a person, it's a really good way because things could be renamed or accidentally named like the same thing, and having that like generic serial number designated off the factory for helps humanity.
This will just take the current JSON document and then serialize it into whatever buffer you pass it. So basically taking the object representation of the JSON and then converting it into a stringified version. The max length is arbitrarily set to 2000 here. We shouldn't ever probably reach that unless Dendrometer has a ton of data in it and we're not even close. So
but if we are getting
we can, yeah.
We know we can.
Yeah.
Great.
Actually, yeah, there's other issues there too. This is I'm not going to explain this very much.
Reads a serial number.
Yeah. Weird pointer location stuff. Data sheet. Look at the data sheet. Pause. Again, it's just like a fancy way to do instead of using delay, which can cause problems because it will hang the whole processor, which you don't really want. While technically also does it, but it still allows the processor to run. It's just stuck in a loop, whereas delay like physically halts the processor. It just waits for a certain amount of time, and then we'll continue to use like normal. And that is the management.
Great. Thanks, Will.
Yeah.
So, let's go ahead and, we'll take questions at the end. We'll stop the recording here and we'll want to pivot to the risk project. But that's a really thorough rundown. Thank you.
Mm-hmm.